Okay. I hope you guys are doing okay. I decided to make a video on the heart and circulation because my class has honors to do, and I know you may not have exactly the time to go and research these things and for yourself. So I'm making this video to kind of summarize everything, and I hope it makes sense to you guys. Okay, so we're starting with number one, the requirements. Right? It says describe the basic function of the following parts of the circulatory system: the heart, the blood vessels, the blood, and the lungs. Okay, so we know for sure that the heart is like a pump, basically. You pump your blood throughout the body to the extremities of your body, from like your fingers and to your toes. Okay, um, you have to understand that we have what scientists call a low surface area to volume ratio. So think about it. We have much less skin than we have insides. Like think of when you think of those diagrams that they show of the anatomy of the human body from the inside, right? You see how much stuff fits inside of us. Now compare that to the amount of skin you see, right? You can see there's a big difference, right? So that explains why we cannot just absorb the nutrients and stuff that we need from the air, like simple bacteria and things. We have a pump, so we have our lungs. So I have to get to that at some point. We have our lungs, which aid the circulatory system, right? And we absorb the oxygen that we need through breathing or inhalation, and the blood, it pumps it in the blood. So the heart is the pump. The blood vessels transport the blood. So if we didn't have blood vessels, the heart pumping would be useless. The blood, of course, it holds oxygen, it holds plasma proteins that help with clotting, it holds, of course, the red blood cells, white blood cells, um, platelets, hormones, all kind of stuff, right? And then we have our lungs. And that, like I was explaining, the lungs is a very, very important organ, okay? We need, all our cells in our body needs oxygen for cellular respiration. And the only way they can get that is, of course, through what we call diffusion. So when we breathe in, right, and our lungs fill with oxygen, the oxygen from the air diffuses into capillaries inside our lungs, right? That's simplifying it. And it gets absorbed into our bloodstream, and then it's transported by the red blood cells in the blood through the blood vessels, and is pumped by the heart to wherever it needs to be in the body. So as you can see, they need each other, they back on each other, and yes, it's a team effort, right? So next, describe the major difference between arteries and veins. All right, okay. So the main difference in arteries and veins is that arteries carry blood away from the heart and veins carry blood to the heart. That's the main thing. So arteries will carry oxygenated blood, right? Most times, but there's one exception, the pulmonary artery. The pulmonary artery, I'll have to show you a diagram at some point, but the pulmonary artery is an exception to that rule, right? It carries blood away from the heart, but the blood is deoxygenated. So the main definition you have to look at is that it carries blood away from the heart. In one example, the only case in the body, there's only one case in the body where that what is transporting out of the blood is deoxygenated, but it's mostly oxygenated blood. And for veins, they'll always be deoxygenated, except for the one exception, of course, the pulmonary vein, which transports oxygenated blood. Right. Now, arteries also have very thick walls. And why? Because, like I said, it transports blood away from the heart. And there is a lot, when the blood comes out of the heart, it has a very high pressure. Right? So the arteries are thick. They are very thick to withstand that pressure. Okay? So what they have is they have thick walls and they have a very narrow, think of a cylinder. They have a very narrow hole in the center, which we call a lumen, and they have very thick walls. right? So that it maintains that pressure throughout the body. It comes from your heart, it goes, some goes down into your body, and some goes up into your, of course, your upper organs, right? And veins. Now, veins are thinner than arteries, and they have a wider, think of the cylinder again, the center, they have a wider center and thinner walls than the artery. But veins have what we call valves. And what valves do is that they prevent the backflow of blood. So think about it. Since I said veins carry deoxygenated blood, let's say an example. Your heart pump oxygenated blood to your, let's think of an organ. Okay, your liver. So the hepatic artery goes to your liver, right? The deoxygenated blood from your liver, right, would have to come up by a vein. Now, by the time that blood going up, right, from your liver to your heart, would have to defy gravity. And would it have a high pressure at that point? No. So what happens is that there are the muscles around your veins contract and pushes the blood up at a low pressure, so it can't really defy gravity. The muscles around the veins contract, which kind of pushes it up. You have to imagine that, right? And they are veins. So once the muscle contracts, the valve behind it closes, so it can't go back down, right? So contract, valve closes, contract, the valve closes, and that helps the blood in the veins to go up, up, up until it gets to the heart, right? And what is the capillary? Capillaries are the smallest blood vessels, and they're extremely thin. So we go in, the arteries are large, the largest, the veins are in the middle, and the capillaries are thinnest things. The walls of the capillaries are actually 1 cell thick. That's how thin it is, right? And that allows nutrients and oxygen and carbon dioxide to diffuse into and out of the capillaries very easily, right? You want them to move in and out, so your cells can get the oxygen and they can remove the carbon dioxide. So that helps them, that benefits them. Okay, and that's the function of the capillaries. Now, identify 2 locations for measuring your pulse and demonstrate your ability to accurately take someone's pulse. All right, so 2 areas to take your pulse. Right, I wanted to show you. So we have here the inside of your elbow, and if most of you look, you will see that there's a vein. For me, it's on my right side. You'll see a vein popping up there. And if you put a finger on it or 2 fingers on it, and you focus, you'll feel that pulsation. You can do it here in this diagram like this, or you can do it here, which is the most common one that you'll see normally, right? You'll feel it here, all right? So demonstrate, you'll have to do that with your parents or your sibling or somebody, right? Next, record your resting pulse rate. Then exercise strenuously, jog, swim laps, for 10 minutes and retake your pulse immediately after exercising, and then again after 5 minutes. Do this each day for 1 week, recording your results on a chart or graph. Did the exercise affect your heart rate? So I want you guys to do this, but I want to explain to you first. So this is a graph, right? Exercise and pulse rate. You should also say the variation between the two. So we have the person's pulse rate, the number of pulse per minute, and the time in minutes. So we can see that the pulse rate was around 64. We're looking at Sam, right? It was around 64, and then it rapidly, you can see that decreases very quickly, and then it goes back down, right? Normally, your pulse is supposed to be somewhere between 60 and 100. Right? That's what you want. That's what you want. But what happens is that the higher it is, it shows that your heart is not working as efficiently as it could, right? Because some athletes, right, when your heart is pumping very efficiently, like the athletes who are fit and stuff like that, their heart rate can be as low as 40 beats per minute. That means in 1 beat, there's no obstruction to the blood in the blood vessels. There's no plaque and fat in the blood vessels. that's clogging it and making the heart have to work hard. The heart tissue is healthy. It's amazing. They are fit. So that's the goal, right? But the average person around 70, between like 60 to 100, that's what we're looking at for the normal person. So we can see that the pulse rate increases here, which means that the person exercise, but um, who's that? Sally may not be as fit as well. Okay, we cannot say that because we can see that Sam's resting pulse was not low to begin with, right? But we can see the difference. So when Sam began to exercise, his pulse didn't increase that much. But then after it decreased and he began to rest. Right? And Sally does low. He exercised, she exercised, it increased, and then it went back down. So another measure of fitness is how long it takes for your pulse to return to normal. So let's say it was 64 beats per minute, and then you exercise for 10 minutes, and then it increases like this. How long does it take for it to return to normal? That is a good question to answer. If you're a fit person, it shouldn't take very long. Once you stop exercising, your heart should start bap, 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 and it should return to normal very quickly. And yeah, right. That's why fit people can catch their breath really easily. So you run, you run, you run. You and the fit person can be burn, burn, burn. But then when you stop, you might take longer to catch your breath than the other person. Right? All right. So we can close these two windows. Yeah, button this. Okay, make a stethoscope and listen to someone's heartbeats. That is a project you must do on your own. I'm sorry. Okay. These 5 things you can do to keep your heart healthy, and put these things into practice if you have not been doing so already. 5 healthy things to do for your heart. Of course, you want to diet. You don't want too much cholesterol. Your body normally produces the amount of cholesterol it needs, so diet high in cholesterol. We'll talk about that next, right? When you talk about arteriosclerosis, I can never pronounce that right? But you don't want diet high in cholesterol. You want to have enough potassium. Potassium helps to regulate your heartbeat. What else do you want? You want your blood to be too thick. So you also want to drink enough water, because if your blood is too thick, it makes it hard on your heart, and that can wear away at the tissue, and that can be bad for you, right? But you can think about exercise, stuff like that, because you don't want too much fat building up in your arteries, stuff like that. Next, what is cholesterol and how is it related to arteriosclerosis? Right. So cholesterol is a type of lipid, right? And lipid is a fat. How is it related to arteria? Okay, right. So what happens is that sometimes, let's talk about somebody who has maybe a high stress job. But let's say, okay, yeah, high stress job. Right? There are 2 parts of your brain. You have in your autonomic nervous system, you have the parasympathetic, which has to do with your resting and digestion of food. You know, you have a normal, you're just resting, you're sleeping, stuff like that. Parasympathetic is taking over. And then there's a sympathetic nervous system. Now, the sympathetic nervous system works with fight or flight. Now, when you're in a high stress, well, when you have a high stress lifestyle, your body will always be or constantly be in that fight mode. Now, if you are always in that fight or flight mode, you are not in rest and digest, and your body does not break down the fats in your diet properly, or anything really properly, right? So what you end up is with a lot of fats in your bloodstream, and those fats can sometimes make your blood very thick. So of course your blood pressure increases because your heart has to work really hard to pump that's a thick substance, your thick blood that you have in your blood vessels. and the increased blood pressure wears away at the arteries, right? Because remember, the arteries put blood away from the heart. So it wears away at the arteries, and sometimes the fat gets stuck in. You see why it wears away at the artery, like it makes a little pocket, and the fat gets stored there, right? And that can stiffen the heart, the arteries. You can actually stiffen the arteries. So the fat gets there, and then the fat just hardens in the artery. You don't want your arteries to be stiff. Okay, wait, yeah. Right. Okay. So we are saying, so when the cholesterol gets stored when the fat gets stored in the pockets of that are made in the arteries, we call that arteriosclerosis, right? And then the stiffness when the arteries become stiff, that's when we call it arteriosclerosis, right? The two words are normally used interchangeably sometimes in the medical community. Right, we are going. Okay, next question. So what is a heart attack and what are its symptoms? Okay, so heart attack, when people say heart attack, you think about the sharp pain in the chest. Um, that's one of the symptoms. That's one of the main symptoms of heart attack that people grasp one immediately, right? But heart attack refers to the death of a segment of the heart muscle, and that's normally caused by a blockage in the blood supply to the heart. So that can happen by a coronary thrombosis, right, which is a blockage or clot in one of the arteries that supplies the heart with blood. If the heart can't get blood, then the heart cells cannot get oxygen. And of course, the heart cells need oxygen for them to keep working hard and pump the blood throughout your body. So you don't want a blockage in one of your coronary arteries. Right. So let me show you a diagram. Right. So you can see here, this is the LAD. You can see there too. The left anterior descending. And this is the main coronary artery. Right? A thrombosis here would lead to a heart attack. When I say thrombosis, I mean a clot. Right? That would lead to a heart attack. Because it means that the cell, this branches off, so that all the heart cells can receive oxygen. So if there's a blockage, let's say here, early on in it, that would lead to a heart attack right there. And we're saying, what are the symptoms? So the common symptoms, there's tightness in the chest, in the neck, your back, your arms. Of course, there's fatigue, because if it's not pumping blood to the rest of your body, then you can't get that energy that you need. There is lightheadedness, of course, and there's arrhythmias. Arrhythmias is the irregular heartbeat. That's a medical term for irregular heartbeat. And how can CPR help? Well, of course, if you have a heart attack and a part of your heart dies, then it can't pump blood to the rest of your body, and of course, the rest of your body needs the blood. So CPR, it helps the body, keeps the heart pumping blood, keeps the heart pumping blood, so that the rest of your body gets the oxygen that it needs. The cells, the rest of your body get the oxygen that it needs to respire and keep them alive. What is an ECG and how is it used by a doctor? So an ECG, right? So electrocardiography is the process of producing an electrocardiogram. It is a graph of voltage versus time of the electrical activity of the heart using electrodes placed on the skin. So in the hospital, when you watch the movies and stuff like that, you normally see people place the wires on the person's chest. That's what they do that for, so they can get this graph. We've seen this before in movies, for sure. Those of you who are cinema fans, you've seen these lines before. That's what they want. So you can see, oh, let me show you that. So you can see what's happening. So I guess that's a contraction of the ventricle, right? Here's what we need. Right. The P wave, QRS complex, T wave. Normal heartbeat, fast heartbeat, slow heartbeat, irregular heartbeats. You can see how it's spaced there. There's a big space between the spikes, small space between the spikes. Kind of average compared to these two, so I can see why it's normal. And irregular is just spikes are close together here, far apart here, this kind of stuff. Okay, so that seems irregular. That makes sense. And find 5 verses. Wait, there's something I wanted to explain here. Right? The electrical pulses. Your heart does operate on electrical pulse. There's a organ, there's a piece of tissue on the right side of the heart called the sinoatrial node or the sinoatrial node. I should pronounce it properly, right? And it sends an electrical impulse to the heart, and that's what causes your heart to pump. It's called the pacemaker of the heart. And when it stops working, that's when they put the electronic pacemaker in the person's chest to help regulate their heartbeat. So anyway, number 10. Find 5 verses in the Bible that refer to your heart and memorize 2 of them. That is a personal activity. Good day, Pathfinders, and good luck.